Good morning, everyone. So, as said, we are online again. Sorry for the there's a lack of, since we had lack of classrooms, we were not able to do online exactly 11 o'clock. So, as you can see, today let us get started with the first concept of class 10 mathematics. We're going to revise the first concept, that is real numbers. So, in real numbers, as you know that we're going to discuss first finding out the HCF. First thing is prime factorization. We will do prime factorization. The second concept is you have already learned prime factorization. On this prime factorization, we are going to gradually develop. What the application is? The application of prime factorization is finding out the HCF and LCM of a number using prime factorization. Then, after finding out the HCF and LCM of given set of numbers, the next concept would be what is the relationship between HCF and LCM and two numbers. That is, the relationship says that HCF into LCM is equal to product of the two numbers. We are going to discuss about these things, and then gradually we will move on to word problems based on HCF and LCM. Once we're done with all these things, the last and final concept is we're going to prove irrationality of numbers. Once again, what we're going to discuss today would be briefly prime factorization, then finding out the HCF and LCM, relationship between HCF and LCM, word problems based on HCF and LCM, and then at the end we're going to prove the irrationality of combinations. Now we will be discussing problems based on application levels. So questions, what we will discuss is based on application level. So today I am going to write some questions on the board. In the future classes, it will be posted on the group so that you can make a note of the questions. Now, first question, let me start with the first question. Now, if M1 and M2 are odd numbers such that M1 is bigger than M2, then M1 square minus M2 square is they have given us four options. First one says an even number. Second option says an odd number. Option C, an odd prime number. Option B says a prime number. So M1 and M2 are odd numbers. M1 and M2 are odd numbers, any odd numbers. If M1 and M2 are any odd numbers, what will be the ending answer? Let me take random odd numbers. Let us start. Always take the simplest of the example. Don't go for complicated numbers. Let me take M1 to be 5, M1 to be 5, and M2 to be M1 3, M1 5. Now, M1 square minus M2 square. M1 is greater than M1 greater than M1. The condition is M1 is greater than M2. So I will take M1 as a greater number, 5 square minus 3 square. 25 minus 9, which is 16. 16 is an even number. Let us start with another simple number like this. Much more simpler. If I take M13, M2, easiest one, I'm going to take 1. 1 and 3 both are odd numbers. Again, I'm going to apply M1 minus M2 square. M1 square is 3 square. M2 is 1 square. 9 minus 1 again. You can see it's an even. So, M1 square minus M2 square, where M1 and M2 are odd numbers, will always end. Will always end. Will always be an even number. So, the option would be A. I started with a slightly bigger number. You can even start with the smallest number. Odd number 1 and 3 can start, it can conclude with the answer. Therefore, M1 square minus M2 square will always be an even number. Now, let me move on to another question. Second question again. By contradictory method, which of the following assumption in the proof of irrationality of root 3. So, by contradictory method, which of the following is necessary assumption? What is the necessary assumption? So, to prove root 3, what is the necessary assumption? To prove root 3, what is the necessary assumption? Root 3 is equal to P by Q, where P and Q are dash numbers. This is the assumption which you make, isn't it? So they have given us options. I'm going to read out the options, but I'm going to be precise and crisp with my answer. I'm going to just write the answer. The question says, by contradictory method, which of the following necessary assumption, I forgot to write necessary assumption in the proof of irrationality of root 3, in the proof of irrationality of root 3. So we have to make what is the assumption? P by Q, where P and Q are, they are mentioned. The first option says P by Q, where P and Q have common factor. Common factor is ruled out. The second option is P and Q are integers. Again, P and Q are integers. That is also ruled out. Why? Because if the numbers are common numbers can be an even integer. It can be integer. Integer is also ruled out. And the next option says that P and Q are co-prime numbers. And the fourth option says that cannot be written in the form of fraction. It says that proving, when you prove root 3 to be an irrational number, you cannot write it in the form of P by. So among the four options, you are familiar with solving this one. Whenever we write root 3 is an irrational number, so we can start making an assumption saying that root 3, let us assume that root 3 is an irrational, is a rational number where P and Q are. So this should be made clear. P and Q are co-prime. P and Q are co-prime. So this is a direct and an easier question. Let me move on to question number 3. Question number 3. Question number 3. Question number 3. If the HCF of 408 and 1032 is of the form 1032 into 2 minus 408 into n, then the value of n is dash. Now, the first thing is they say that HCF of 408 and 1032 is expressible in the form of 1032 into 2 minus 408 into 10. If it is written in this form, what is the value of n? For this, we have to first figure out what is the HCF of 408 and 1032. So let us find out the HCF of 408 and 1032. 2 zeros are 2 fours are again 2 ones are 0 twos are 2 fives are 1s are 3 ones are 3 sevens are. Again, let me write the number 1032. 2 fives are 10. 2 ones are to carry on 2 six are 2 twos are carry on 2 fives are 2 eights are. Again 2 ones are 2 twos are carry on 2 nines are 80. 3 fours are 12. 3 threes are 3 fours are 12. 3 threes are 9. Again 43 is a prime. 43 is a prime number. It is just 2 ones are 2 twos are 4 carry on 2 nines are 80. 3 fours are 12. 3 threes are 9. So HCF would be outside here 2 cube into 3 into 43, and that is for the number 1032. For 408, prime factors are 2 cube into 3 into 30. Therefore, HCF would be, you very well know that what is the HCF? 2 cube followed by 3. That is 8 into 3. 20. HCF is 20. Now we got to the HCF is 24. Now let us simplify this one. HCF is in the form of 1032 into 2 minus 408 into n. HCF is 24. HCF is 24 is equal to. Let me multiply these two numbers. 2 twos are 4, 2 threes are 6, 0, 2 minus 408. Let me transpose and let me simplify the equation. 408 n is equal to 2064 minus 24. 2064 minus 24. 2040 is equal to 408 n. N is equal to 2040 divided by 480. On simplifying, you have to find out the value of n. So when you simplify, we get the value of n as the value of n is. So this would be the steps needed. This is a higher order differential equation and it is an MCQ question. for standard paper. It's a standard paper question. So options were given. The four options were 4, 5, 3, and 2. So the value of n is 5. Please make a note. Please make a note. We should go with the next one. Make a note.
Sir. Okay.
Meantime, let me write the next question. I will start with word problem. Word problem. Tab A opens every 20 minutes and tab B opens every 25 minutes. If both are open, if both are open together at 9 a.m. at 9 a.m. After how many minutes? After how many minutes will they next? After how many minutes will they next open together? So again, a similar question we have discussed. The question was based on traffic light problems. So usually a very frequent as question. 3 traffic signals, they change after every time will be given. So they will start off, all the 3 signals will be started at 9 o'clock. When will they again become green for the first time? Based on the same concept, we have the next question. So both tab A and tab B. Tab A opens every 20 minutes, whereas tab B opens every 25 minutes. Now, if both are open together, they both are open at 9 a.m. After how many minutes will they open together next time? I repeat once again. They both are open at 9 a.m. After how many minutes when will they both open together again? So the only question should come to your mind is 20 and 25. Let me check with another. Yes, 25. 20 and 25. Now, 9 o'clock they both open. The only thing which should come to your mind is it HCF or LCM? So you might have known that if you have a word minimum, maximum, then if you have the word minimum, we use LCM. If you have the word maximum, we use LCM. In this particular question, we don't have any word minimum, least, small, or maximum, highest, biggest. Now, in this particular case, if I take the HCF of 20 and 25 is HCF 20 and 25 is 5. Now, both the tap are opened at 9 o'clock. Now, if I take HCF as 5, they both will open again at what time? 9 o'clock 5 minutes, which is impossible. Why impossible? Because the first tap itself will take 20 minutes. So again opening the tap at 9 o'clock 5 minutes is impossible. So I repeat once again, if I take HCF, HCF will be smaller number, and I cannot have a smaller number here. Why I cannot have a smaller number? Because if I take the HCF of 20 and 25, the HCF is 5, and I cannot have the answer as 5 because 9 o'clock the taps are open. The next time the tap will open is at 9:20 for the first one. So if I write the answer as 5 minutes, 9 o'clock 5 minutes, my answer is wrong, which indirectly tells that I want a number which is bigger than 20 and 25. HCF is not possible. Why? Because if I take HCF, it will be a smaller number, and nowhere the taps are going to open at 9:20 or as well as 9:25. It will be a bigger number, now more than 20 and 25. So which means that bigger number I'm going to take, which means that it should be what? LCM. So again I repeat, if I take HCF 5 minutes will be the HCF, and tap can never open at what? 9 o'clock 5 minutes. Why? Because the first tap itself will take how much? 5 minutes. It will take, sorry, it will take 20 minutes. So the answer will become wrong. So be careful. We should take LCM. Now LCM of 20 and 25. LCM of 20, let me write the prime factors for 20. 2 square and 5. 25 5 square. Therefore LCM is 2 square and 5 square, which is 4 into 25. Answer is 100 minutes. After 100 minutes, the taps will be opened together. 2 square. See the HCF is, sorry, LCM is what? Highest power of 2, highest power of 5 apparently. Highest power of 2 is 2, highest power of 5 is 2, 2 square is 4, 5 square is 25. 4 into 25 is 100. So after 100 minutes, that is 100 minutes means 1 hour 40 minutes. 100 minutes is the number 1 hour 40 minutes, isn't it? 1 hour 40 minutes. 9 o'clock it opened first. 9 o'clock it opened first. So again it will be opened at 10 o'clock 40 minutes. 9 a.m. it was opened first. The next time when both the taps will be opened together will be 40 minutes. That is 1 hour 40 minutes. 100 minutes, sorry, 100 minutes, which we convert in terms of hours, it will become 1 hour 40 minutes. 1 hour 40 minutes. So 9 o'clock, after 9 o'clock, 100 minutes would be 10 o'clock 40 minutes. 10:40, they both will be open. Please make a note. These are the application level questions which we are going to discuss now. Let me write a question. A simple one let me take. By the time you write the answer, let me write a question on the other side of the board. Simple but tricky question. What is the HCF of a very regularly asked question? Smallest prime and the smallest prime and smallest composite. Smallest prime and smallest composite number. 2-mark question. So, if you are done with this one, anyhow the video will be available. If you're done with this one, I'm going to erase this part. You can come back to the video. Now let me get started with the next question. A very simple one. A very simple question. Question is written on the board. You can go to the question. Question number 5. What is the HCF of smallest prime number? Smallest prime. Smallest prime, you very well know that smallest prime is 2. Smallest composite. Smallest composite number is 4. Now HCF of these two numbers. HCF 2 is 2 to the power 2, 4 is 2 square. HCF, the smallest power of the common. HCF is. Now, same question in another paper, they have asked in a different way. What is the ratio they have asked? Same question can be asked in a different way. What is the ratio of HCF and LCM? What is the ratio of HCF and LCM of same thing? Smallest prime and composite number. Same question in a different way. Same question, I had seen this particular question in one of the sample papers, both sample papers. Most probably might be in the year 23 or 24. What is the ratio of HCF and LCM of smallest prime and smallest composite number? Anyhow, they are written the smallest prime number is 2, smallest composite number is 4. HCF I have already written here. Let me write the LCM to this. LCM would be the highest power of the numbers present in it. So the highest power of 2 is 2 square. That is. Now, the next question says that you have to find the ratio of HCF to LCM. HCF to LCM. So HCF is how much? LCM is the ratio would become 1 is to 2. 1 is to 2. Again, I repeat. Concept are slightly different, but the question almost resembles. Here they are speaking about smallest composite and prime. Even here, smallest composite and prime. Here we are supposed to find out HCF. In this particular concept, we have to find the ratio of HCF to LCM. So, a small tricky question usually is make a note. Usually what they do, when they say smallest prime number, the immediate thing which comes to your mind is they go for 3. So be careful, the smallest prime number is 2. And 2 is the only even prime number, all other prime numbers are odd. So please make a note. Let me take some previous papers, higher order chemistry questions. 2025 paper. As I have mentioned, we have 16 regional offices. So each regional office will have 3 sets of standard paper, 3 sets of basic papers. So you might be knowing, therefore 16 3 is 48 different papers will be having. So no 2 papers will be same. The next one again, look at the 25 paper. Question number 7, let me start. If minus 1 to the power n plus minus 1 to the power 8 is equal to 0, then n is option A, positive integer, option B, negative integer, C, any odd number, D, any even number, any even number. Now, minus 1 to the power n is minus 1 to the power 8 is equal to 0. So you very well know that negative number to the power 8, even number, this always will be this always will be positive. Minus 1 whole to the power 8. Negative integer to the power even will always become positive. So this is plus 1 and this has to be minus 1. Plus 1 minus 1. Plus 1 minus 1 gets cancelled, therefore the answer is 0. But to be negative, the number to be negative here, this should be odd. We very well know that minus negative number to the power odd. Negative number, and if the power is odd, the number will always be negative. So here n should be any odd number. Any odd number. Let me take an example. Minus 1 to the power 8. If I take an odd number 3, minus 1 to the power 3 is minus 1. Plus minus 1 to the power 8 even, this is plus 1, which is, you can check even with 1 or 5 or 7 or 9, this always will end up as what? Negative. Therefore, n should be a odd, any odd number. Any odd number is the right option. Any odd number. Same way, let me take the next question. Which of the following? Which of the following? Which of the following cannot be okay, fine, cannot be the unit digit of 8 to the power n, where n is a natural number. Option 4 to 0, and the last one 6. Last one 6. Now, which of the following cannot be the unit digits? Unit digit of 8 to the power n. So you have learned that 8 to the power n, or any number to the power n, to end with the digit 0. You have learned that any number to the power n, to end with the digit 0, it should have both 2 and 5 as the prime factors. So here 8 to the power n, 8 to the power n, this you have learned in your exercise problem, saying that it will never end with the digit 0. This will never end with the digit 0. Why? Because prime factorization of 8 is 2 cube. For a number to end with the digit 0, an example it will be 10, 2 into 5, 20, 2 square into 5, 30, 2 into 3 into 5. See, always we get what? 2 and 5. But 8 does not have, it has 2 but does not have 5. Therefore, this will never end with 0. So according to that, which of the following cannot be unit digits of 8 to the power n? 4 can be the unit digits. 8 square is 64. Yes, true. And again, if I take 3, 8 to the power 3 will end with 3. And again, if you take some other number, it will end with 6. But 8 to the power n can never end with the digit 0. It will never end with the digit 0. So this is your basics of prime factorization. Any number to end with 0, its prime factor should always contain 2 and 5. 8 does not have 5, therefore it will not end with 5. Therefore, according to this particular question, the answer should be the number a to the power n, where n is any natural number, will never end with a digit 0. So this should be your, please make a note. Let me write the question on the other side of the board. The next question, question number 9. Let me check whether question number 9 will be on the screen right side. It's not visible. Question number 9. Question number 9. Yes. Right question. I might be reading this part of the course and we will this part. Question number 9. If x is the, I repeat, if x is the LCM of 4, 6, 8 and y is the LCM of 3, 5, 7 and p is the LCM of x and y, then which of the following is true? A right option. Option A, p is equal to 35x. Option B, p is equal to 4y. Option C, p is equal to 8x. Option D, p is equal to 16y. Okay. Yes. The descriptive part is clear. So first, let us find out the LCM of 4, 6, 8. LCM of 4, 6, 8. I shall use the regular method. 4, 6, 8. 2 2s are, 2 3s are, 2 4s are, 2 1s are, 2 2s are, 2 1s are. I am using the traditional method of finding out the LCM. LCM of 4, 6, 8 is 2 cube and 3. That is 8 into 3, 24. Same way, LCM of 3, 5, 7. You very well know that 3, 5, 7 are co-prime numbers. They don't have any common factor. So LCM of co-prime numbers will always be product of the number. So directly you can write 3 into 5 into 7. 7 5s are 35. 35 into 3. 35 into 3 is 10. Now, we found the LCM of 4, 6, 8. And now, as well as we found the LCM of 3, 5, 7. The next part of the question says if P is the LCM of, so LCM of x comma y is P. LCM of 24 and 105 is P. Let me find out the LCM of 105 and 105 and 105 and 24. 24 is nothing but 2 cube into 3 and 105 is nothing but 8 into 5 into 7. So let me write from here itself. LCM is highest power of 2, highest power of 3, highest power of 5, highest power of 6. T. So now 2 cube is 8 into 3 into 5 into 7. So now let us check which of the option matches our answer. Here x is what? X is nothing but LCM of this is your x and this is your x is 24, y is 105. I repeat once again, x is nothing but the LCM of 4, comma 6, comma 8. So LCM of 4, 6, 8 is how much? 20. LCM of 3, 5, 7 is 10. Now let us check this one. Now let us check. If I take 5 into 3, 5 7 35, 105. Here I get 105, 105, which is nothing but y into 8. Do we have that option? 105 into 8, y into 8. We don't have that option. Y into 8 is not there. Let us try to mismatch the numbers here. Let us try to mismatch. 7 5 is a 35, 7 5 is a 35, 8 3 is a 24. Let me just mismatch the numbers. 8 3 is a 24 into 35. 24 here, x into 35. Observe, I am using the same numbers present over there. So I see that we have 35 and x. X is nothing but 8 is I match it here, 8 is a 24. And 3 5 is a, sorry, 7 5 is 35. So 24 is nothing but x into 35 is equal to 3. Observe which option matches over here. Option 3. I repeat, x is nothing but LCM of 4, 6, 8. Y is the LCM of 3, 5, 7, which is 105. On simplifying, I get 8 3 is 8 into 3 into 5 into 7 is equal to 3. I'm going to match those numbers. So if I try matching those numbers, first option will be 7 5 to 35, right as it is. The left out is what? 8 is at 24. I go back to this one. 24 is what? X. 35 we don't have anything here, and there 35 as it is. X into 35, which is option B. Therefore, P is equal to 35 X, which is option B. Again, 2025 2025 board exam paper, standard papers answer. Standard paper, question paper, standard paper. Another simple question. We have read also. 10. If HCF of 98, 28 is 10 and LCM of 98 and 28 is n, then the value of n minus 7 is, then the value of n minus 7 is. Again, they have given us 4 options. I'll write the options. Zero, 28, 98, 19. Now first we have to find out the HCF of 98 and 28. HCF of 98 and 28. Find out the HCF of 98 and 28. 98. 98 is 49 2s are 2 into 7 square. 28 4 7s are 4 7 4 can be written as 2 square equals 7. Now HCF HCF is 2 into 7 50. LCM 2 square into 7 square 4 into 40 196. Now they say that find the value. So here n is this is your n is your. So m is the HCF, n is the LCM. So we put here n minus 7 is equal to n is 14 minus 7 into simplify this. You have to simplify this too. N is sorry, I wrote that way. N is 196 minus 7 times 7 times. Simplify. So n minus 7 and how much do you get? We have to find. M is 14, n is 196 minus 7 times 14. Simplify. Simplify, you get the required answer. 196 minus 7 4s are 28, 7 1s are 89. So 196 minus 98 will be the required answer. 196 minus 98, 98 is the required answer. Please make a note. Please make a note. Okay. Let me go with the next one. The greatest number which divides 70 and 125, leaving the remainders 5 and 8 respectively. Leaving remainders 5 and 8 respectively. Is again an MCQ question. Again an MCQ question. Again, an easy question. Let me write the options. 13, 65, 875, 875, 1750. Now, the greatest number, when you come across the word greatest number, it means that you have to find out the HCF of the two numbers. HCF of the what? HCF of 70 and 125, but after subtracting the greatest number which divides 70 and 125. But the catch over here, it's leaving remainder 5 both. It's leaving remainder 5 in the first case and 8 in the next case. So we're going to subtract 5 from the first number, subtract 8 from the next number, and then after that, HCF we will find. Why? Because they use the word greatest. So HCF of 65 and 117. So we have learned 65 and 117, 30 is HCF. I'll show you how it's done. 65 into 5, 13 is 117, 3, 9 is 3, 3 is 9, carry 2, 3, 9 is 3, 30 is. Therefore, 65 is 5 into 13, 170 is 3 square into 13. So you can clearly see that HCF is 13. So 70 when divided by 13, 70 when divided by 13 will leave a remainder how much? 5. Same, 125 when divided by 13, it will leave a remainder. Therefore, the biggest number which can divide both numbers, leaving remainder 5 and 8 is the HCF of 65 and 170, that is 13. Make a note. Find I forgot the problem of Euclid. Find the smallest number that is divisible by both 644 and 460. So you all are familiar. This is a 2-mark question. Year 2025. Smallest number that is divisible by, smallest means nothing but you have to find out LCM of 64 and 462. Carry the prime factorization for 64 was 644, 644, 2 3s are 2 is 2 1s are 6 2 1s are 2, 5 and 6 are. Now carry prime factorization for the next numbers. Similarly, it's not divisible by 3, not divisible by 3, 6, 7, 8, not divisible by 3. Next number 5, not divisible by 5. Let us check with 7. 7 2s are 40, carry 2, 7 3s are. Again, 462, 2 2s are, 3s are, 1s are. 2 plus 3 is 5, 5 plus 1 is 6. 6 is divisible by 3. Therefore, 231 is divisible by 3. 3 7s are, carry 2, 3 7s are. 7. 3 7s are 21. We have 23, carry 2. 3 7s are 21 again. 7 11s are. Therefore, LCM would be C then 2 square. Then highest power of 3 is 3. Then 7 then 11, then 2 square into 3 into 7 into 11 into 20. 2 square is 4, 3s are 12, 12 into 77 into 23. Write the required answer. Write the required answer. That would be the biggest number. That would be the biggest number. 2, 1, 2, 5. This is the smallest number. Sorry, this is the smallest number which is divisible by both 644 and 462. The smallest number which can divide 644 and 462 is 21,250. 21,200. Move on to the next question. Two numbers are in the ratio 4:5, and here HCF is 11. Find the LCM of these two numbers. Find the LCM of these numbers. Now, let me read the question. Two numbers are in the ratio 4:5. 4:5, and HCF is 11. So find the numbers. Find the LCM of these numbers. No, here. HCF of 4, let the numbers be. Let me write the numbers to be. 4:5. You very well know that whenever you have ratios, we write let the numbers be 4x and 5x. HCF of 4x and 5x is 11. See, the HCF is here, x is the HCF of 4x and 5x is 11. So the common number over here is x is the common number. 4 and 5 are co-prime numbers. X is the common number. Therefore, HCF is nothing but 11. That is, the value of x is 11. If x is 11, 4x would be 4 times 11, 44. 5x would be 5 times 11 is 55. Now you have to find the LCM. You have to find the LCM of 44 and 5. So you can use any traditional method you can use, or you can go at this same 11 4s are 11 5s are 5 2 2s are 2. Therefore, LCM is 2 square into 5 into 11. 2 square into 5 into 11. 2 square into 5 would be 2 square is 4, 5 4s are 20. 20 into 11 is 200. So the LCM would be 220. LCM would be 4 5s are 20. 220 is the LCM. 220 is the LCM. So we are doing all the application level questions. We are doing all the application level questions. Now gradually, let me move on to another question which is based on class 9, not 10, based on 9. Question says 0.4 is or an option B. Natural number. integer, rational and irrational. Rational, irrational. You have to decide now whether it is option A, option B, or option C, or A, B, C, or D. Square root of 0.4 can be written as 4 by 10. Root 4 by root 10. Root 4 is 2 by 10. This is 2 is a rational number. 10 is an irrational number. So rational divided by irrational number, which is nothing but irrational. When you rationalize the denominator, so observe here, 2 root 10 divided by root 10 to root 10 becomes, so root 10 by 5, again which is a irrational number. So we need not worry, whenever your numerator or denominator, if it is rational and other term is irrational, it will always be nothing but a irrational number. So root 0.4 is irrational. Root 0.4 is irrational number. Now, 2 or 3 problems are to discuss on based on class 9 concepts, which they have asked in the previous year papers. We write the next question here. The smallest irrational number by which root 20 should be multiplied so as to get a rational number is so as to get a rational number is. So root 20 So by what smaller number? I'll write the options here. Option A, B, C, that we write 20, root 20, root 20, root 2, 5 root 5. First let me write root 20 is the simplest form. Root 20 can be written as 4 times 5. Root 4 is 2. Root 5. Now the smallest number by which this should be multiplied. Smallest number which should be multiplied by this number so that it becomes rational. See that? 2 root 5. So the smallest number, I should take it from here. I cannot take root 2. If I take root 2 into root 5, root 2 becomes root 10. If I take 20, not possible. Observe now, smallest number among there, irrational. See that? This is irrational, this is irrational, this is irrational, this is rational. So when I multiply 2 root 5 with root 5, what do I get? Rational. Therefore, the smallest number by which root 20 should be multiplied to make it rational number is option B. Option, make a note. This is concept based on class 9, not exactly like class 9. Now this chapter concepts are based on only these things: irrational numbers, HCF, LCM, and you all are familiar with rationalizing, proving irrationality of a number, which is very familiar, but you have to see to that you practice those things. That is proving irrationality. To prove root 2, root 3, root 5. These questions are very frequently asked, and you all are well versed with this one. Please practice these questions as well as problems based on numbers which has both rational and irrational, proving set of numbers which contain both rational and irrational numbers. So these questions need to be practiced by you, which are very familiar, which we have discussed in the previous classes. Now, the concepts which we just now dealt with are all higher order thinking skill questions, or we can say that application questions we have dealt with. These are all regularly asked questions. Regularly asked. This is not an application question. This is just a routine question which you have to practice for board exams. And the only thing which you can expect from class 10 from textbook is these are questions. Other questions are rarely asked, they won't be repeated from the textbook, but especially from real numbers, the question which you can predict is root 2, root 3, root 5, or 3 plus root 5, or 7 minus root 2, or it might be a mix of set of numbers, right? So these questions should be practiced by you. So today we'll be stopping it over here. Next class we'll be starting with polynomials. So we're going to deal with all standard questions and questions, application questions, which is going to be asked in basic paper as well. I repeat once again. Next class we're going to start with polynomials. I'm going to be able to discuss all the application level questions based on standard as well as application level questions based on basic papers. We're going to gather all the information from recently released sample papers, and we're going to discuss the questions. And we'll see that we post the questions prior to the class. Just before we start the class, we'll have questions being posted on the group, and we'll discuss the question which is posted on the. Okay, students. Today we'll stop it over here, and till we meet next class, have a great day. Thank you.
Okay, sir.